Hi, my name is Shahnawaz. We begin this lecture with the following lemma. So let P from the space x tilde x be a covering map. Let f and g from 0, 1 to x be paths in x, which agree at the endpoints. That is, f of 0 is same as g of 0, and f of 1 is same as g of 1. Let us suppose f tilde and g tilde be their lifts. So let f tilde, so let this f tilde and g tilde be the maps from interval 0, 1 to x tilde, such that p composite with f tilde is f, and p composite with g tilde is g. Suppose f tilde and g tilde agree at the first point. So suppose f tilde of 0 is g tilde of 0, i.e. they agree at the initial point. Then they agree at the final point if and only if then f tilde of 1 is g tilde of 1 if and only if the loop f of f product with g inverse, so this is a loop and this is a homotopy class. So if this belongs to the image of the induced map P star, which is a homomorphism from the fundamental group of uh, x tilde based at x naught to the fundamental group of x based at p of x naught tilde. So this is the image of the map P star. So this is x tilde and x naught tilde. This x naught tilde is such that, so where x naught tilde is same as f tilde of 0, which is same as g tilde of 0. So let us prove this. So what we are given, so we have the space x tilde here and the space x here. This is the covering map P. Here we have the interval 0, 1, and from 0, 1 to x we have two maps. One is f and other is g. So we have like this. So this is f and this is g, and f tilde and g tilde are the lifts of f and g respectively. So this is f tilde and this is g tilde. So first of all, these f tilde and g tilde, they agree at the initial point, and we call this initial point as x naught tilde. So this is x naught tilde, and then we have these two letters f tilde and g tilde. So this is f tilde and this is g tilde. Now we have to prove these 2 points agree if and only if the loop. So since this is over f which starts at f of 0 which is same as g of 0, and then we have the map g which is like this. So g inverse will be a map in this direction. So f product with g inverse will be a loop based at this point which is f of 0, or let us call this x naught, where this p of x naught tilde is p of x. So let p of x naught tilde is x naught and gamma be equal to f product with g inverse, that is this. So then gamma is another path from the interval 0 1 to x. So this is given as, so gamma of s is actually f of 2s if this s lies between 0 and half, and this is g inverse of 1 minus 2s if half is less than or equal to x is less or equal to 1. Or so since this g inverse of s is same as g of 1 minus s, we can write this gamma as, so we can write this gamma of s as f of 2s if this s is between 0 and half, and this is g of 1 minus, sorry, this is 2, um, g inverse 1 minus 2s can be written as g of 1 minus 1 minus 2s. Sorry, this is 2s minus 1 here because at half we have g of 0. So this is equal to g of 1 minus 2 minus 1 minus 2s minus 1, that is plus 1. So this is 2 minus 2s if s lies between half and 1. Now one can note that, so note that gamma is continuous because it is a product of two continuous maps. So note that gamma is continuous. And gamma of 0 which is f of 0, but f of 0 is given to be equal to g of 0. So if we look at this set here, g of 0 is same as gamma of 1 because gamma of 1 is g of 0. This is gamma of 1. So that means uh, gamma at the initial point and gamma at the final point is same. That means this gamma is actually a loop, that is this path here which is gamma. So this is a loop, this starts at this point f of 0 which is x naught. So this is a loop. So therefore gamma is a loop based at, so it's a loop in x based at x naught. Now we can invoke the path lifting property here to get a lift of this gamma. So therefore by path lifting property. So therefore by path lifting property, there exists a unique path, say gamma tilde from 0 1 to x tilde, such that this gamma tilde starts at x naught tilde and p composite with gamma tilde is gamma, which is same as f dot g inverse. So this would imply that implies that so if I restrict this p of gamma tilde to the first interval, this implies that sorry this implies that p of gamma tilde restricted to the interval 0 half, this is actually f, and p of gamma tilde restricted to the next half, so this is actually g inverse. Now let us suppose so what we have to prove, we have to prove this uh, f tilde of 1 is g tilde of 1 if and only if this thing is true. So we are going to assume f tilde of 1 is g tilde of 1, then we'll prove that this homotopy class is in the image of p star. So let the homotopy class of gamma, which is the homotopy class of f dot g inverse, belongs to the image of to the image of the homomorphism p star from pi 1 x tilde x naught tilde to pi 1 of x naught, i.e. we assume that this homotopy class f dot g inverse, this is in p star of pi 1 of x tilde x naught tilde. So then by consequence second, now since f dot g bar is actually, let us call this, so let us call this gamma. So since uh, this gamma has the unit to gamma tilde, so then by consequence second, which we did in the last lecture, it states that the lift of gamma will be actually a loop based at x naught tilde. So then by consequence second, um, gamma, the lift of gamma tilde, the lift of gamma tilde, sorry, the lift of gamma tilde of gamma is a loop in x tilde based at x naught tilde. Also we have p composite of f is f tilde. Sorry, p composite of f tilde is f, and p composite of g tilde is g. So by the uniqueness of these letters f tilde and g tilde, so what this would imply, one can note here we have p composite of uh, I mean f is same as p composite of gamma tilde restricted at 0 1. So then therefore therefore this p composite with gamma tilde restricted at 0 half is f, and p composite with gamma tilde restricted at the next half is g inverse. Uh, Now by the uniqueness of these letters f tilde and g tilde we have, so therefore or hence by the uniqueness of mm, letters of f and g, I mean let us write this way, by the uniqueness of letters f tilde and g tilde of f and g respectively, we have this. I think I have made a mistake here. So we are comparing this equation with this equation. So we get here p of f tilde, and here we have and here we have p composed with g tilde is g. So here we have the map. So this is actually, so mm, I mean if we restrict this thing over 0 1 we get ffs, and if we restrict this thing over s we have a map g of s which is same as g of 1 minus s. So we can write this down here. So when we restrict this over s we get f tilde of s, and if we restrict to this map, I mean if we operate this map over s we get g of 1 minus s. Now so this is p of g of 1 minus s. So this is p of g of 1 minus s. Now we have f tilde and g tilde to be the unique lift of f and g. So we get, therefore we have um, I mean we have this f tilde of s will be gamma tilde of s by 2, because this is arrested over 0 and half, and g tilde of and the g tilde of s will be gamma tilde of 1 by 2 of 2s minus 2 minus s. So uh, in particular f tilde of 1 will be equal to gamma tilde of half, and gamma tilde of half is same as g tilde of 1, because g tilde of 1 is gamma tilde of half. So that means f tilde and g tilde agree at the endpoint as well. Now conversely, let f tilde of 1 is g tilde of 1. So then for the path, gamma from 0 1 to x, mm, the unique continuous lift gamma tilde of gamma. Now we have to prove this. The homotopy class of gamma is in the image of the fundamental group uh, of x tilde based at x naught under the map p star. So, so there is a continuous lift gamma tilde of gamma starting at x naught tilde. So this is given by, because this lift is unique, so we are like this. So here we have the loop gamma, which is like this. First we travel f, then we travel g backwards, so we get the loop gamma, which starts at the point x naught. Here we have the interval 0 1, and here we have the two maps f tilde and g tilde. So this is f tilde and this is g tilde, and this is the point x naught tilde. This is f tilde and this is g tilde. Now since this uh, for this gamma, which is a loop based at x naught in x, we have a unique lift gamma tilde of y. So this gamma tilde of y must be equal to then, because here we have this loop here f tilde product with g tilde inverse. So this loop over here must be equal to our gamma tilde. So this will start at x naught tilde, which is given by gamma tilde of s will be the product of f tilde dot g tilde inverse, which is same as, first we travel f tilde at the two times speed in the interval 0 to half, then we travel g tilde inverse in the next half interval at twice the speed. So if this 0 is half is less or equal to s is less or equal to 1, or this gamma tilde of s will be f tilde of 2s. If 0 is less or equal to s is less or equal to 1, it is g tilde of 2 minus 2s if this s is between the half and 1. Now, but gamma tilde of 1, which is x naught tilde, is same as gamma tilde of 0, because this is our map gamma tilde. So gamma tilde is a loop based at x naught tilde. So this is a loop in x tilde based at x naught tilde. So since p composite with gamma tilde is gamma, therefore or we can write this as, so since p composite with gamma tilde is gamma, or p star of the homotopy class of gamma tilde is, or we can write this as, so since p composite with gamma tilde is gamma, we have the homotopy class of p composite with gamma tilde is actually the homotopy class of gamma, and hence p star of gamma tilde will be gamma. So note that p star of the homotopy class of f is given as the homotopy class of p composite f. So we are using the definition of p star here. So hence hence this uh, gamma must belong to, so this belongs to the p star of pi 1 of x tilde based at x naught tilde. So this proves the converse part.